Hello viewers, welcome to UNC Digital class. So in today's class we will be discuss the next type of linked list, that is double linked list. We have already discussed about single linked list. How can we create the node in single linked list, and we can also insert a new node into an existing list, and also we can delete a node from an existing linked list. So in this class we will be discuss about double linked list. In case of single linked list, we will traverse from beginning of the node to end of the node. But in case of double linked list, we can traverse the node in two ways. That means in forward traversal and backward traversal. That means from starting node to ending node at the last node is the forward traversal, and we can also traverse the list from last node to first node or the starting node, that is your backward traversal, that linked list. Okay. Then what is the structure of the double linked list? As we are traversing forward traversal and backward traversal, in single linked list we need only one address. That means we need only the forward node address to traverse for forward traversing. But as in double linked list we are traversing forward as well as backward, so we need the next node address as well as previous node address to traverse the double linked list. Okay. Then next we will know what is the structure of the double linked list. In single linked list, each node contain one data part or information part, and next one is, and the another part is your next part or address part, which hold the address of the next node. But in double linked list, it has three parts. That means each node has three parts. That is, one is your data part and another two are the address part. One will contain the next node address and next one will contain the previous node address. Then what is the structure of the double linked list node? The structure of the double linked list node is like this. Each node has three parts. One is the data part or information part, which contain the data which will be input according to program. Then this one is the pre-pointer, okay, and this one is your next pointer. This pre-pointer will hold the address of the previous node, okay, and this next pointer will hold address of the next node. Okay, it will hold the address of previous node and it will hold the address of next node, and this is the data part of the double linked list. Okay, you just see the structure of the double linked list. In single linked list, how can we declare this structure of the node? In single linked list, we declare one integer number which hold the information part of the node and another a struct node type pointer which hold the address of next node. But in double linked list, what will be the structure declaration for node? The structure declaration for node is struct node. Okay, you can see this is the structure of the double linked list. In double linked list, it has one info part. Suppose that info part contain one integer data, so we declare it int info. Then next we must declare two pointer which hold the next node address as well as previous node address. So for that I can write struct node because it will hold the address of a node and it will also hold the address of a node. So we must declare the same type of pointer which hold the address of the node. So the data type becomes struct node pre. This pre-pointer hold address of the previous node and this next pointer will hold address of the next node. This is the structure declaration for double linked list. Okay, or this is the node structure, and when we declare this, the node will be created in this form. Okay, so next we will see how can we create the number of nodes in double linked list. When we want to create number of node in double linked list, so we must call a function which create the number of nodes in double linked list as like our single linked list. So here I am defining a function which create the number of node in double linked list. Suppose that function is DL underscore create, that is the user defined function. You can specify any name according to your choice. Okay, and as we know that in single linked list, every time the create function will return a address to its calling part, and as it is return a node address, so this can be held by a struct node pointer. Okay, so the return type of the DL create function is struct node stat. That means every time this function will return the address of the stat node. So as it returning the address of a node, so the data type is struct node stat, and the name of the user defined function is DL, that is double linked list. You can specify any name, DL underscore create. Okay, and as like single linked list, it always receive the static node address. So it will receive stack node stat. Okay, this is the function. And what are the minimum requirement of variables before we executing the create function? We must declare these variables. Suppose these variables are struct node stat, which is initialized as null, and suppose there is another pointer, suppose q. Okay, and when we declare this variable stat equals to null, this is the pointer stat initialized as null. Okay, then next we will declare another struct node type pointer, suppose that is new. Okay, this pointer I declared here to hold the address of the new node which we want to create in the double linked list. Okay, as it hold the address of a node, so data type is also struct node type pointer. Okay, then I can write new equals to struct node star malloc size of struct node star. Okay, when I declare this, okay, that means this malloc function used to create the node of structure struct node type. You can see the struct node type structure is one info part and two address part. Okay, that means when I execute this will create a node containing one info part and two address part. One is your pre and another one is your next. Suppose this is created our memory location 100. Okay, and this will be held by the variable new. Okay, so initially when I declare new, initially it initialized as null, and when I execute this statement, then the address of the new node is assigned to the pointer variable new. So new became 100. Okay, next we will input the number which will be stored at the info part of the node, which the address of that node is held by the new node. Okay, for that I can declare a integer type variable, suppose is int no. Okay, now I have to input the value for the variable no. So I can write printf enter the number. Okay, then scanf %d ampersand no. Okay, when I execute this statement, so it means what? No be a integer variable which will hold a integer constant after executing these two printf and scanf statement. Suppose here I am inputting the value for the variable no is 10. That means now no contain 10. Then next what I will be do? Then next I will be store this value at the info part of the node. Okay, this address is held by the variable new. For that I can write new info equals to no. Okay, that means at the info part of the new I will store 10, and next I will set the null value at the pre part and next part of the new node which is recently created. So I can write new pre equals to new next equals to null. So when I execute this, the null value is set at the pre part as well as next part of the new node. Okay, then I will start to create the node. So for that I will first check the stat node is created in the list or not. In the static node I can write if stat equals to null. It means what? Still there is no node in the double linked list. Now we will be create the first node in the double linked list by writing stat equals to new. It means the new node which is created, that is became the stat node of the list. So I can write stat equals to new. Okay. When I write start equals to new, then this will be set as 100 and start will point to this node. Okay. Now new point to this node as well as start point to this node. Okay. Suppose next I want to create another node in double linked list. So for that I will be execute again for the create function, that is dl underscore create function, and later we will be discuss about else part. Just call the dl create function for creating next node or another node in double linked list. When I execute this function, okay, that means when I call this function, again this function will receive the start node address. That means the stat became 100. So this will receive by the stat pointer. Okay. Then comes to again this part. Again when I execute this statement, a new pointer is declared, and when I execute this, a new node is created of structure like this, one info part, and there must be a pre part and next part. So the next node is created when I execute new stack node malloc size of stack node. Okay, and now new point to this node. Okay, suppose this is created at the 200 location, and next I will be import the value for the info part of the new node, and that value is stored in the no. Suppose no will store 200, and I executing this new info equals to no, new pre equals to new next equals to null, the node becomes 20 and this is null. Okay, then comes to this point. Okay, then next we will be check that any node is created in the double linked list or not. So for that I will be execute that if start equals to null. If this condition is true, then no node will be created. We just discussed about this. That means here this condition is false because we have already created a node in double linked list. So as this condition is false, so we will be go from if part to else part. Now we will be create the next node in the double linked list. Okay. The next node in the double linked list we will be declare another pointer that I have already declared, that is suppose q. So here I can write q equals to stat because we will traverse to the last node of the double linked list, and for that I will be execute a loop. So I can write while q next is not equals to null, then I will be set q equals to q next. Okay, let me execute this loop first. Okay, when I write q equals to start, so q will become a pointer and which will be initially null, and when I write this statement, so q becomes 100 because q equals to start and the start value is 100. So next we will be execute the loop to, or we have to move to the last node of the double linked list. So I will be check q next is not equals to null. So Q is 100 and Q next is not equals to null. The condition is false. As this condition is false, then we will not go for this. Okay, then we will exit from this loop to this loop, and when we exit from this to this location, now we will be link the two nodes which are created in the double linked list, that is this one and this one. Okay, so this address is held by the pointer variable Q also, and now we will be link these two. That means how can we link these two? We can store the address of new node at the next part of the queue and the address of the queue node at the pre part of the new. Okay, so for that I can write Q next equals to new. Okay, so new became 200. You can see new point at 200 node. So when I write Q next equals to new, so this new node address will store at the next part of the queue. Q is 100. You can see Q is 100. At the next part of the 100, we will store 200. So now this will be point and our forward traversing is going on. But we know that in double linked list, we can also traverse in backward. So for backward traversal, we will be stored at the pre part of the new node the value of this node, this previous node, that is 100, and 100 is held by the pointer variable Q. So I can write new pre equals to Q. Okay, and this will become 100, and we can also go for the backward traverse. So now we can see we can link the two node in the double linked list. In the same process, we can also create another node in double linked list. Suppose we want to create another node, and when we want to create another node, then we must execute the DL underscore create function. And when we go for executing DL create function, it will first receive the start node address, and which will be also held by the start pointer. So it becomes 100. You can see it becomes 100, and now we will again declare a variable new which is initially null, and by executing new struct node malloc size of struct node, a new node is created. Suppose this was the new node which is created in the double linked list. Suppose at 300 location. Now we will import the data for the new node, and that will be held by the variable no. You can see here I am declaring a variable no, and here I am inputting the value for the variable no. Suppose no will hold 30, and the pre part and the next part of the new node is set as null. So it becomes 30, and the pre part and the next part of the new node is set as null. Okay, in the similar process, we will first check that any node is created in the double linked list or not. For that, we can execute a if statement. If start equals to null, this condition is false. We know that because start is 100. As this condition is false, then we will go for the else part. In else part, we will assign the start value to the variable q. So q becomes 100. Okay, and we will execute the loop to move to the last node of the double linked list. So I will check the condition. Q next is not equals to null. So q is 100. Okay, that is not equals to null. The condition is true because the next content 200. As this condition is true, so we will execute this statement, that is q equals to q next. So q becomes 200, and again we will go for this q next is not equals to null. That means 200 next. So 200 next is not equals to null. Condition is false. As this condition is false, then we will exit from this to this, and when we exit from loop, now we will link the second node with the third node of the double linked list. Okay, so for that I can write q next equals to new. So this is point by new. Okay, q next is equals to new. It means the new value, that means the new pointer hold the value, that value will be stored at the next part of the queue. So q is 200. At the next part of the queue, I will be stored 300, and this will be point to the new node. I will be also link the forward traversal nodes. So for that I can write new pre equals to q. So new is your 300. At the pre part of the new I will be store q. So q is 200. Then here I am writing 200, and when I writing this will point to this, and you can see we can traverse forward and we can also traverse backward. Okay, we will end the else block. Okay, as every time we will return the stat node address according to our function prototype. So we will be execute a statement that is return stat here after the end of the else part as well as end of the if part, that is return stat. Okay, then next end the create function block. So this will be end the create function block. Okay, so this is all about how we can create the number of nodes in double linked list. Thank you. Have a nice day.